Laws of exponents. We're going to cover some of the basic laws of exponents. The first one here. When you multiply two numbers with the same base, you just add the powers. So like 2 to the third times 2 to the fifth. They both have the same base of 2, so you just get 2 to the 3 plus 5, which is 8. Likewise, if you divide two things with the same base, you subtract the exponents. 2 to the fifth over 2 to the third. Oh, they both have the same base, so 2 to the 5 minus 3, or 2 squared. A power to a power, you raise a power to a power, that's when you multiply the exponents. So 2 to the third to the fifth power, you multiply those exponents, you get 2 to the 3 times 5, or 2 to the 15th. You can distribute over powers. So again, as long as there's not a plus or minus in between, as long as it's not a binomial, you're able to distribute. So 2x to the fourth would get you 2 to the fourth, x to the fourth. And likewise, when you divide, keep in mind anything to the 0 power is automatically 1. That's because when you take something to the 0 power, you write it over itself. So hence you get 1. So anything to the 0 power is automatically 1. This is also why you can't be 0, because it doesn't work when it's 0, because you can't have 0 over 0. You can't divide it. And lastly, a negative power flips. Right? So if you have, let me erase some of this. If you have 3 to the negative 2, that's the same thing as saying 1 over 3 squared. And likewise, if you have 1 over 2 to the negative 4, it's the same thing as saying you flip it up, 2 over 2 to the 4th, or 1. So those are the basic rules. Now we're just going to apply real quick. First one here, 7 to the 4th times 7 to the 5th. We'll use to add the powers, you get 7 to the 9th, 4 plus 5. Same thing here, that's going to be p to the 8th. Over here, you're multiplying three things, it's okay, they all have the same base. So you get 2 to the 4th plus negative 2 plus negative 1, which gets you 2 to the 1st. If we want to simplify this, remember, dividing and subtracting, so I'm going to get 6 minus 3, which gets me 5 to the 3rd. 11 minus 6, which will give me x to the 5th. This is a fun one. 3 minus negative 1, double negative makes a positive, so I get a to the 4th. Another way to think about that, though, is I would just flip the negative up there, so I have a cubed times a to the 1st, which also gets me a to the 4th. This one, so in this case, you could kind of do the same thing. We could subtract it, x to the negative 2 minus 3, so I get x to the negative 5. Now you're not supposed to have a negative as your answer, so we have to flip it down, 1 over x to the 5th. That's why actually the way I would have done it, since I know the negative rule, I would have moved this to the bottom because we're not supposed to have negatives in our answer. Negative powers in our answer, so it would have been 1 over x squared x cubed, which would have been 1 over x to the 5th. x1. So these are powers to a power, so we're going to multiply. So it's be 3 to the 5 times 2. So it'd be 10. This one's x to the 3 times x to the 3rd to the k power. So again, you just multiply. So it'd be x to the 3k. Next one, 3 to the 0 to the 4 power. So again, you multiply the powers. It'd be 3 to the 0, which is just 1. This one looks funky. It's w7p divided by w. Now again, when you see a number and it has no power, it's a power of 1. And again, I gotta combine these. I can't have two separate. I can't have the same number on both top and bottom, same base. So you gotta combine it. Oh, it's subtraction. Remember, top minus bottom, 7p minus 1. That'll be my answer there. Right? So anytime you don't see a power, it is a power of 1. You can't have you can't have the same base on top and bottom. You gotta simplify it. Write these as a power of 2. So 16 is just 2 to the 4th. Down here, you could do the same thing. That's 1 over 2 to the 4th. How do you write 1 as a power of 2? Remember, anything to the 0 power is 1. So that's the way you do it. How about this? I have 4 times 2 to the n power. So what we have to do here is try to get them both to be the same power of 2. So I'm going to write 4 as 2 squared. And multiply by 2 to the n. Now these have the same base, so you get to add the powers. So 2 to the n plus 2. That's the way that works. Right, so again, I had to write 4. Since I want them to write them all with the power of 2, I get 4 and 2 to be the same base of 2. So 4 is 2 squared. And then once you have this same base, add the powers. See my idea here. I'm gonna write 8 as 2 cubed. This is 2 to the m. Now they have the same base, I can combine them, top minus bottom, so I get 2 to the m minus 3. That's my answer there. Same idea, but write it to the power of 3. So I'm going to change 27 to 3 cubed times 3 to the d Now they have the same base, I can add the powers. So d plus 3. Over here, same concept, a little more fancy. 9, I'm going to change that to 3 squared, n plus 1, over 3 to the 2n minus 1. Now watch out here. So that, see how 2 is inside the parentheses because you changed 9 to 3 squared? That 2 has to distribute to both of these guys. So I'm going to get 3 to the 2n plus 2 over 3 to the 2n minus 1. Now what they do here? Well, they have the same base, so we're going to subtract powers. Again, you got to watch your parentheses. So it's 3, the top, 2n plus 2, minus the bottom. Make sure to put in parentheses, because you got to subtract the whole bottom. So parentheses, distribute the negative, 3 to the 2n plus 2, minus 2n plus 1. Add, oh, these cancel. I just add like terms, 3 cubed, or 27. Next one, express in exponent form with a prime base number. So they just want you to rewrite these, kind of like what we just did. So like 9 to the 4th, 9 is not prime, they want you to rewrite it. I could write 9 as 3 squared to the 4th, and then now it's a power to a power, so 3 to the 8th. You multiply those guys. Same thing here. So 3x is fine, 9x is not okay, that's not a prime, so make it 3 squared to the y, also known as 3x over 3 to the 2y. Remember, you multiply the powers, so 2 times y is just 2y. And now they have the same base, so you subtract. So it's going to be top minus bottom, x minus 2y. I'm going to do some a little faster, 25x, that's the same as saying 5 squared x, so 5 to the 2x. Again, power to power, you multiply. Next one, 16k over 4k. Well, I can change 16 to 4 squared to the k power, so this would be 4 to the 2k over 4k. Again, once they have the same base, you just subtract the exponent, so it would be 4 to the 2k minus k, or 4k. This one right here, same idea. Top power, they have the same base, so top minus bottom. Don't forget to distribute the negative. So I get negative x plus 1, so I get 2 x's cancel out to the third power. We're going to simplify this. So the general rule here is you can't have a negative exponent. That you're not allowed to have that. So like you see here, you have to flip it. So 7 to the 0 and 10 to the power is 1. Here you can have a negative exponent, so you have to flip it. 1 over 3 squared. Here, well, 3 to the 0 is 1. And then this you got to flip, so 1/3. So this is 1 minus 1/3, which if I was going to simplify would be common denominator, so 2/3. This one, that negative goes to both of them, so it becomes like 5 to the negative 2 or 3 to the negative 2. Well, now they both have negative exponents, so you just flip it. So it becomes 3 squared over 5 squared. Or if you want, 9 over 25. Right, using the powers of 2, 3, or 5. So this one, 6, I could break down to 2 times 3 to the p power. 5, what's 5? Let's see, 75 divided by 5 is 15. So it's 5, 3. So it's 5 squared times 3. All things they want here, right? This p right here I can distribute. So 2p times 3p over 3 times 5 squared. Right, so just to recap, they want me to write it with powers of 2, 3, or 5. So I changed 6p to 2 times 3, but with a p on top. So then I had to distribute. So I get that. 75 I had to break down, so 75 is 5 times 15, which is 5 times 3, so I get 5 squared times 3, so I rewrote it like this. But now remember I said earlier, you can't have the same base on top and bottom, so you have to simplify that. So we're going to simplify this guy and this guy. Well, remember you just subtract, so it's going to be 2p times 3 to the p minus 1, because that's p and that's 1, all over 5 squared. And I believe that's all you can do with this problem. Okay, last few. Write in simplest forms, all we can do here is distribute. So I'm going to get negative 3 to the 4th and a to the 8th. If you want, you can simplify some more. 3 to the 4th is 81, so minus 80, negative 81, a to the 8th. Over here, same concept. Again, notice there's no, it's not a binomial, it's a monomial. So you distribute this 3 to everything. You get 2 to the 3rd, negative it stays, it's an odd power, so you get to keep the negative. A to the 6, b to the 3rd. That's all I could do there. This one here, we're going to distribute. Now remember, if you don't see a power, it's a power of 1. X squared times x to the 1st is x to the 3rd minus 2x squared plus x squared times x to the negative 1. Again, you add the powers, so 2 plus negative 1 is just x. So it looks like that. Simplify using law of exponents. So same thing here. Now, when you multiply these two, it's like when you do radicals. You multiply the numbers by themselves, so 8, and then you multiply the powers by themselves, so 9. Same thing here, 15 over 3, it's going to give me 5, and then simplify the powers, t squared. Over here, let's simplify it all. So on top I get, top I get k to the 8th. On the bottom, power to power gets you k to the 6th. Right, so on top I just add them because you're multiplying the same base, so you add the powers. On the bottom, so powers to powers, so you multiply them. And then here you can simplify, they have the same base, top minus bottom, k squared, because 8 minus 6 is 2. Right, without using negative exponents. So first I got to distribute. So I get 2 to the negative 4, c to the negative 12. Now I want to know negative exponents, so they both flip. 1 over 2 to the 4, c to the 12. Next one, you only flip the stuff that has a negative exponent. So that's only the a and the c. C would move up, the a would move down. So I'm going to get b squared c over a cubed. Let me answer there. Write without a fraction. So they want to write this without a fraction. So the only thing I could do... Okay, I was trying to think of how to do this one. So at first I was thinking, honestly, you can just flip it up. Right? They want you to write without a fraction, just flip it up. So 2, you have to negate it, so watch how you negate it. Right, so you flip it up, it's like that. Remember, you don't, so you distribute the negative. And I get 2 to the negative 1 plus n, or if you want, 2 to the n plus 1, minus 1. So let's do that one. Here, they have the same base, so it's a little easier, you just subtract. So a negative n minus parentheses 2 plus n, don't forget the parentheses. So you distribute. I get negative 2 minus n, add like terms, a to the negative 2 minus 2n, or negative 2 minus 2. Here, you want without a fraction, so all I'm going to do here is move these powers to the top. Remember, if you don't see a power on the x, it's a 1, so that becomes 7x minus 4x to the negative 1, and over here becomes 5x to the negative 2. And then the last one here, we want to write these without fractions. All we're going to do is separate it. So I'm going to put x squared over x plus 3x over x plus 2 over x. You see the split up? This is x. These x's cancel, you get 3. And this is 2 over x. Now again, I want to know fractions, so I'm going to move this to the top and make it a negative. So it's x plus 3 plus 2x to the negative 1. I'm going to do the same thing with this one. You're going to split it, because there's only one thing on the bottom, the monomial. Simplify it. Now remember, you can either move this to the top and makes it a positive, or subtract. Either way, you should get 2x to the 7 plus x to the 4th plus 3x to the 3rd. And that's the lesson.